You've probably heard the stories, right? The infamous hemi-tick, camshafts failing way too early, bearing issues popping up in engines that are practically brand new. It really feels like modern engines just aren't built like they used to be. But what if the problem isn't the engine parts themselves? What if it's something we think we know inside and out? Motor oil. Let's get into it.
I mean, today's engines are just incredible. Seriously, you've got variable valve timing, displacement on demand, turbos on everything. They're squeezing out more power and getting better mileage than anyone thought possible a few decades back. They really are masterpieces of engineering.
And that's the big question, isn't it? If these things are so advanced, why are we seeing so many of them suffer these expensive, premature failures? Well, the answer, it turns out, comes down to a huge misunderstanding of what motor oil is actually doing inside a modern engine. Look, we all know oil is for lubricating, right? It cools, it cleans. That's what we were all taught. But in today's engines, it's been given a brand new, critical second job, a secret hydraulic role that honestly changes everything.
Yep, you heard that right. Your motor oil is also being used as a hydraulic fluid. And this isn't just some small technical detail. This is the absolute key to unlocking the whole mystery of why these incredible engines can be so fragile.
So what does that actually mean? Well, it means the oil itself is being put under intense pressure to physically move parts around. We're talking about things like your cam phasers for the variable valve timing, or those lifters that shut down cylinders to save fuel. All of those systems depend on clean oil at exactly the right pressure to work. And right there, that's where the trouble starts.
And check this out. This quote, it doesn't even come from the car world. This is from industrial and aerospace engineering. You know, fields where hydraulic failures are absolutely not an option. For them, this isn't just a catchy phrase. It's a fundamental law.
Because as soon as you start thinking of oil as a hydraulic fluid, its number one enemy isn't heat, it's not shearing, it's not breaking down. It's one simple thing: contamination. And the scale of this problem is, well, it's staggering. Get ready for this number. Data from study after study from huge names like Chevron and Timken all points to the same thing. A whopping 82% of all mechanical wear is caused by tiny particles. We're talking about dirt, dust, and little bits of metal just circulating around and around in your oil. But here is the really sneaky part. The particles that do almost all of the damage, you can't even see them. The human eye can't really spot anything smaller than about 40 microns, but the particles that are wrecking your engine's sensitive hydraulic parts are often smaller than 20 microns. They're literally invisible assassins floating in your oil. So how can a particle that's too small to see cause a huge failure? It's a process called subsurface fatigue. The best way to think about it is like a pothole forming in the street. It doesn't start from the top, it starts with pressure underneath. In your engine, a tiny hard particle gets caught and squeezed between two metal parts, like a roller lifter and a camshaft. All that force gets focused on one microscopic point, which creates a tiny crack below the surface. Do that millions of times, and that crack grows and grows until eventually, pop, a piece of metal breaks off. And that's your catastrophic failure. Okay, so if contamination is the villain and cleanliness is the hero, then we have to completely rethink the most basic maintenance we do on our cars, the oil change. Now here's a fact that goes against what a lot of people believe. Engines are not broken in from the factory. The data is absolutely clear. The highest rate of wear an engine will ever experience in its entire life happens right at the very beginning. Let's just look at the data. When you analyze thousands of oil samples, you see that the amount of wear metals and other junk in the oil during the first 10,000 miles is often 3 times higher than what you'll see later on. This is that critical break-in period where all the fresh metal surfaces are wearing against each other and creating a ton of debris. And this right here is why following the manufacturer's advice to wait 5,000 or even 10,000 miles for that first oil change can be so damaging. It means all that gritty, abrasive break-in material is just left to circulate through your brand new engine, grinding away at those super precise hydraulic parts for thousands and thousands of miles. So what's the smarter way to do it? You have to be dynamic. For that first 10,000 miles during break-in, you want to do frequent oil changes to get all that nasty debris out of there. Then, during the engine's mid-life, say up to 100,000 miles, you can actually extend your oil changes because the engine is clean and the filter's working at peak efficiency. And then, as the engine gets older, you shorten the intervals again as wear starts to increase. It's about matching your maintenance to the engine's life stage. Okay, let's put all this together. Here is a simple, actionable playbook to help you protect your engine and make it last. So here are the 4 big rules. Number 1, adapt your oil change interval. Don't stick to one number for the engine's whole life. 2, choose high-efficiency filters, not high-flow. You want a filter that's good at catching those tiny invisible particles. 3, use top-tier gasoline. It's got better detergents that keep your fuel injectors clean, which prevents raw gas from washing into your oil and thinning it out. And finally, number 4, avoid solid particle additives. I mean, think about it. Why on earth would you intentionally add particles to your oil when the entire goal is to get them out?
At the end of the day, it all comes down to this simple idea. Every big, catastrophic failure, it always starts at the microscopic level. Those massive engine-out repair bills don't just happen out of nowhere. They're the end result of millions and millions of tiny, invisible wear events that have been adding up over time. So I'll just leave you with this final thought. We spend so much time and energy arguing about oil brands, weights, and all these different specs. But based on everything we've seen, maybe the single most important question we should be asking is a lot simpler. How clean is it?